We're going on to topic 4 now of chapter 5. We're going to look at trinomials of the type x squared plus bx plus c, keeping in mind that if we put an a there, this is referred to as the standard form of the quadratic expression. But notice that the a in these down here is just a 1. So in this section, we're going to learn how to factor these, and then keeping in mind looking for the zeros, the technique that we had earlier. Now, again, where did this trinomial come from? Well, it came from the FOIL. We're assuming that when we joined our like terms, we got our middle term. So what we're going to be doing here is undoing the FOIL. And that's what we want to work on. Now, again, there's a lot of strategy involved, and you want to have a protocol, a method of doing this. So as we see this first term, is it in standard form? That is descending powers, and yes. Is there a factor we can take out of each term? No. Then the next thing we're going to do is put 2 sets of parentheses right underneath it. This is what they're doing here. And then we're going to say for the FOIL, what were the possibilities in our first place here to give us this term? And it's an x and an x. Now we're looking for factors then of this last term, which is 6, that would add up to a positive 5. So they're starting us off with an easy one. That's nice. And it's a 3 and a 2. And then we look at the signs, and we're going to see these are all plus, so these would be all plus. So the simplest one would be something like so. And you can read some of this other, where they say, what are all the factors and things? And the nice thing about the textbook is that they show you various things. Now, our last term here is a positive 6. And if our middle term happened to be, instead of a positive 5, was a negative 5, then the signs of these two terms would have been negative, because negative times negative also makes a positive. But now when you added the outers and the inners, you ended up with a negative 5. Okay, so again, they're showing when the last term is positive, internally you're going to need the same signs, whether they're both negative, but that will give you a negative 7x, or they're both positive, that will give you a positive 7x. Let's continue. Once again, the textbook is meant to be read, looked at, and we're just going over it a little bit here to develop some strategies and to have it interpreted a little bit. Is it in standard form? Yes. Is there a common factor? No. So I usually like to put it underneath, but I'll put it to the side. Then what we do is we put two sets of parentheses. Now, since our a term over here is 1, and we have a t squared, then the first thing we do is just put a t in both of these positions. Then mentally we start thinking of what are the factors of 20 that will add up to a 9. Happens to be a negative 9. So we know both of these are going to be negative in order to get a positive. Well, you can go 1 times 20, 2 times 10, 4 times 5, and you might say, wait a minute, 4 times 5, when we add them up, that adds up to 9, so we've hit on it. And then how do you check it? You check it by FOIL, and there's your factorization. Now, as we look at example 3, again, there's more reading, but let's just go right directly to a summation, sort of. Is it in standard form? Yes. Is there a common factor we can take out of each one? And the answer is yes. You can factor out an x from each term. So this will give you an x squared minus x minus 30. Now, no more common factors. It's in standard form. Again, you put two sets of parentheses, and you know this is going to be an x and an x. And again, we're looking for factors of 30 that have a difference of 1. Well, 6 times 5. Now, what will our signs be? We know one's going to be positive and one will be negative to give our 30 here a negative. And since our middle term is a negative, the larger of our n terms will be negative. The other will be positive. And how do you check it? You check it by the FOIL. So your outers are 5, inners negative, and you end up with a negative 1, and that is correct. Now I do, in other sections on our YouTube series, a whole page of factoring, and there they are. Notice they had it switched around a little bit. That's perfectly fine. Now, if you put this into a graphic calculator, you might see what answers you would get. Now, they're going to show us something, and I guess I could show it to you right now, that suppose this original thing was an equation, that is, it equals 0. This y over here was 0. Then we'd see one of our answers is this, one is this, and one is that. And you might say, how did we get that? Well, again, this is 0, and what we did in the last section, take each of our factors, equal it to 0, these are our 3 factors, equaling it to 0. So, one factor will be 0. This, when we transpose it, will be a negative 5. So, and then this one would transpose and become a 6. So there's our, again, a little T-chart. It's very useful. and we have a 0, 0, 0. So when y is 0, here this will be a negative 5. When it's 0, it's also 0. That's this one. And this one is a positive 6. So we're just anticipating a little bit what we're going to do when we factor these things. And you'll have some exercises to try. Now, here are some others. And again, the strategy, once again, put them in standard form, 2 sets of parentheses, factors of 21 that here have a difference of 4. Well, 3 and 7. Now keep in mind, if our 4 is a negative, then the 7 will be negative and the 3 will be positive. If the 4 is a positive, then the 7's a positive and the 3 is negative. And you might say, well, how do you check this? Well, you check it by foiling, and that will be practice to improve your FOIL. Now for number 4, as we look at it, is it in standard form? And the answer is no. So the first thing you do is put it in standard form. And then 2 sets of parentheses. Here our a is 1, so it's just going to be t and t. And then factors of 24 that have a difference of 5, it'll be 8 and 3. And as you do these, you go through the different factors mentally. And since this 5 is positive, the larger number will be positive. And that will be negative. And you FOIL it, and it checks out. Now for number 5, and again, the book gives a lot more information. We're going through it a little bit quickly. It's in standard form. Our a is 1, so it's x and x. And factors of 7. And you might say, there are no factors of 7 that have a difference of 1. So this is prime. You tried it, you looked at it. In fact, I wouldn't have even have put the parentheses there, but that would be your protocol. Now, hopefully you're keeping a homework log that is a record of all that you've done. Here's a little summary of it. And here is number 6. Again, it's in standard form. But notice we have the descending of x powers, ascending of y powers. No common factor. So 2 sets of parentheses. The x will go there, and we know a y is going to go there as well. So we've set it up. Now it's a -2 difference. We're looking for factors of 48 that have a difference of 2. And it will be 6 and 8. 6 times 8 is 48. Our middle term is a negative, so the larger number would be negative, and this would be positive. And there you see it down here. Now, when we have equations containing a trinomial that's equal to 0, there is a strategy, and in a sense, this could be put into a graphing calculator, and there are your answers, but we want to do it by factoring. So the strategy would be 2 sets of parentheses, equal to 0. It's in standard form. XX. Now 8 times 1 is 8, but when we add them together, our outers and inners, it adds up to 9, and they're both going to be positive. And then we just take each factor, equal it to 0, and when it's something like this, they just transpose, and there's our -8, and there's our -1. These, we have found the zeros, and it checks. Now, as you look at this one, you might say, is this in standard form if we wanted to solve what t was? And the answer is no, because it's not equal to 0. Remember, we can only use the principle of the zero product if it equals 0 over here. So what do we need to do? Well, we need to FOIL this, get that. We need to move the -24 over to this side, where it becomes a +24, and a -10 gives us a 14. Now we have to factor this into its factors, equate each of its factors to 0, transpose, and we have t equals 2 or t equals 7. And then they're just showing part of the graph. There's our 2, and there's our 7. Okay? Now we did this one earlier, so I'm not going to do it again. We had this, we put it in standard form, we factored out the x, we factored what remained. We have 3 solutions. And then why? Because this is a qubit equation. That indicates we're going to need 3 solutions. Here are our 3 solutions, and we saw it on a graph earlier. Now, some of these, when they get to be quite large, they're asking us to factor this, and it comes out here to a -19 and a 32. So that would be kind of difficult to figure, but they work pretty much the same way. And not every trinomial is factorable. If they're not factorable, they could still be solved, but they can't be solved by factoring. And we'll be doing some of this in chapter 8. So we're just starting off here in the beginning. Now, here's one in which we are to work backwards. Here they're saying the function of this, whose zeros are these, what would the equation be? Well, let's just do this over here on the side. Well, we know that if these are our answers, that this was x equals 0, x equals -1, and here x equals 3. Now let's take that back a step. Well, this was x. This in a parenthesis was x plus 1. This in a parenthesis was x minus 3. And we said all of that equals 0. We're just working backwards. So now we're going to FOIL this. This is x squared. My outer's a negative 3. So this will be a negative 2x minus 3 equals 0. And then now I'm going to multiply everything by x. So I get x to the third minus 2x squared minus 3x equals 0. And then in function notation, I would take this away and just put f of x there. Okay? They have it worked out for you here. This is the strategy. And did we skip a page? Maybe. Oh, we're getting on to our exercise set. So again, this is what you'll be doing for practice and as you work on your skills, your quiz me's.